Hello and welcome to Geeks for Geeks. The problem which we are going to see today is to segregate zeros and ones in an array. So in this problem, you will be given an array of zeros and ones in random order. So the zeros and ones can appear in any order. And you have to basically segregate zeros on the left side and ones on the right side. So let us see it with an example. So the given input array. So suppose you are given this input array. So you see that 0 is followed by 1, then followed by 0, then 1, 0, 0, 1, 1, then 0. So zeros and ones are placed in random order in this array. So you will be given this type of an array, and the output array should actually have zeros on the left side and then ones on the right side. So in this input array, there were 5 zeros and 5 ones. So that is why we have 5 zeros here, followed by 5 ones at the rightmost side. Okay, so let us look at the methods to solve this problem. So the first method is to count zeros or ones. So in this problem, in this solution, basically, you will be counting the number of zeros. So let us say that the number of zeros are C. So once we have the count, we can put C number of zeros at the beginning and then ones at the remaining places. That would be n minus C. The time complexity of this solution will be order of n. Why? Because you will be traversing the whole of the array to count the number of zeros. So that can be done in order of n time complexity. And then you'll have to place the C zeros at the beginning and n minus C ones at the end. So that can again, this step can also be done in n time complexity. So n plus n gives n time complexity in order of n. Okay, so this problem can be solved in order of n time complexity, but the thing is that this method traverses the array 2 times. So can we do better? Can we can we solve this problem by traversing the array only once? Let us see. So in this second method, which we are going to see, we are going to use 2 index variables to traverse the array. So in this problem, we maintain 2 indexes. We initialize the first index left as 0 and the second index right as n minus 1. So there are 2 index variables, left and right. Left is initialized with 0, right is initialized with n minus 1. Then initialize this of the initialization step. Then as per the algorithm, what we'll do is till the time left is smaller than right, we'll keep incrementing the index left while there are zeros in it. We'll then keep decrementing the index right while there are ones at it. So what we are doing is, because we initialize the left variable with 0, so we first of all see how many zeros are there from the left side. So as soon as we encounter the first one from the left side, we stop there. So this step stops there. Again, for the index variable right, we initialize it with n minus 1 and then we keep on decrementing it till we keep on seeing the ones. Once we see a 0, we stop. So this is the second step. Now in the third step, we check that if left is smaller than right. So if left is smaller than right, then what we do is we just exchange the array element at left index and array element at right index. So this will be basically 1 here, and this will be 2. So we'll be, oh sorry, this will be 0. So we'll be swapping the values 0 with 1, thereby placing them at the correct positions. Now once we have done that, then we'll again follow this step 1 and step 2, and then subsequently step 3. So uh, so we will keep on doing these steps until unless left is smaller than right. Once the left is greater than right, then basically we would have traversed the whole array and we would have placed all the elements at the right position. So the output array would have been formed. Okay, so let's see at what's the implementation. So this is the driver function here. So in this driver function, we have the array, then we have an index I, then we are calculating the size of the array. Okay, so this I variable will be basically used to print the array after we are done with the segregation of zeros and ones. So the main function which will be doing the job for us is segregate 0 and 1, which takes as an argument the whole array and its size. Let's see how segregate 0 and 1 works. So in this function, as we saw in the driver function, we have the array and its size. So then we do the initialization steps. So we initialize left with 0 and right with size -1. Then we run a while loop till left is smaller than right. Once left is greater than right, then we would have traversed the whole array and would have got the output array. So we run a loop having the condition left should be smaller than right. Then we increment the left index while we see zeros on the left. So we have array left is equal to 0 and left is smaller than right. So we do this step, we increment left plus plus. So once we encounter a 1, then we do not increment the left variable and we stay there. So we do the same thing for the right variable. The difference is that we check for the variable for the value 1, and if we encounter any 0, then we stop there. If we don't encounter 0, we keep on decrementing the right variable. So once these two steps are done, then if left is smaller than right, then we basically have uh, array of left equal to 1 and array of right equal to 0. So we'll just swap it. So instead of swapping, because we know the values 0 and 1, so we can actually just place the values. So array of left will be 0, array of right will be 1. And then we increment left and decrement right, because left and right, the values at left and right index are at correct positions. So once this whole while condition gets through and the loop breaks, so at the end of it, we'll have the correct output array. So in this video, we basically saw two methods to solve this problem. Both the solutions had the time complexity of order of n, but the method 2 had an edge over method 1. Why? Because method 1 was traversing the array twice, whereas the method 2 traverses the array only once. So that is all for this tutorial. Do visit this link. You can find all the stuff we discussed in this video, and you can also run the code which we just discussed in the IDE on the Geeks for Geeks website itself. Thank you very much.